So we're ready for lesson 3. And in this lesson, we're going to be working with parallel and perpendicular lines. So in our previous lesson, we reminded ourselves of how to determine slope and how to write equations of lines. So from each, I want us to take a look at each of these examples. So for each pair of lines, I want us to really think about the similarities and the differences. And so I have two lines here, and one of the things that I think is happening is that these lines look like they will never intersect. I know they're lines, they have arrows at the ends. I think that these lines are parallel, but I really need to make sure that they are parallel. So the first thing, let's talk about the difference or the distance, the vertical distance between each line. So if you take a look at this and you look at the vertical distance, the vertical distance between these two lines remain the same. Okay, so this, now it looks like a ladder. So these two lines, the distance between the two lines is the same between any two pair of points. So from here to here, here to here, all of those distances are the same. So let's take a look over here. I wonder if that's the case here as well. These two lines do look parallel. So let's take a look at some differences. So if I look at this distance between here and here, let's say here and here, here and here, what do you notice about these distances? The distance between points from one graph to another is the same. And that will be true for all pair of parallel lines. So same distance here and same distance here. Okay, so that's definitely some characteristics. So parallel lines are going, and because these distances are the same, that means that these lines are never going to intersect. And so parallel lines are going to be lines that never intersect. And I want us to take a look at and realize what about it mathematically indicates that these lines are parallel. Okay, so I want us to ultimately write the equation for each line in example A. We have two lines. I want us to think about what's needed. Line number 1, line number 2. So I want us to think about what's needed in order to write the equation for a line. Well, in our intro lesson, our review of Algebra 1 in our previous video, we talked about there's two forms of equations that we can work with. We have slope-intercept. Remember, that's y equals mx plus b. That's your slope-intercept. We also have point-slope form, which is y minus y1 equals m times x minus x1. And that's our point-slope form. So depending on the information that we can get from our lines, that will kind of dictate which form we need to use. So let's take line 1. Okay, I need the slope and the y-intercept. So for line 1, let's go down here. So see how much I can scoot this up. So for line 1, my slope, how can I find the slope of the line for line 1? Well, let's just do a rise over run. So let's find a point that's a good point that might be easy for us to see. that ends up at the crosshairs. So I'm going to go up 2, right 3, I'm going to rise 2, run 3. Since I've gone up 2, right 3, up 2, right 3, slope being rise over run, let me scoot up, I'm going to get a slope of 2/3. So this line right here has a slope of 2/3. So line 1's slope is 2/3. The y-intercept is a point that we can determine from the graph, and that is at 2. So the y-intercept, B, is 2. So we have enough to write the equation for line 1. I've got the slope, I've got the y-intercept. I'm going to write the equation using slope-intercept form. So y equals mx plus b. So y equals, my slope is 2/3. My b is 2. So my equation for line 1 is y equals 2/3 x plus 2. So now I want us to find the equation for line 2. So let's see what we can determine from this line. Well, let's first, we can identify the y-intercept. There's the point for the y-intercept. So I know the y-intercept is -1. Now let's determine the slope. So this is going to be kind of hard because I've written all over it. So I'm going to go up. Here's a good point right here. From here to here, I have to go up 2, right 3. Well, what about here? No, I don't like that point. What about right here? Here's a good point. I go up 2, right 3. So I went up 2, right 3, up 2, right 3. So this also has a slope using rise over run of 2/3 as well. So my equation, again, because I have the slope and the y-intercept, let me scoot this up. Because I have the slope and the y-intercept, I'm going to use slope-intercept form to write my equation, and that will be y equals 2/3 x plus, nope, that's not plus. What is b? B is -1, so that's 2/3 x minus 1. And so here's the equation for line number 2. Now, if you look at these two equations, what do those two equations have in common? Well, the slope of this line is 2/3, and the slope of this line is also 2/3. 2/3, 2/3. Let's write the equation. Let's also do the same thing for these two equations. Let's write the equation for each line in example B. Okay, so let's I'll let this line be line 1, and we'll let this darker line be line 2. So let's start with line 1. Let's see what we can determine from line 1. Can we determine the y-intercept? Yes. So I have the y-intercept. Whoops, let's do this. So for line 1, the b value is 7. Now I need to find the slope. So I want to find another point that's a good point for me to use this rise over run. So that's not, here's a good one because the point is right there at the crosshairs of the x and y. So let's see what I have to do. I have to go down 1, 2, 3, and over 2. So this is 3, this is 2. How about down 3, right 2? So there's another down 3, right 2. Now, this line is falling, and because we had to go down 3, so because we went down 3, going down means negative. So our slope, rise over run, our rise was -3 since we went down, and we ran 2. So down 3 makes that -3, right 2, +2, down 3, right 2. So I have my slope and I have my y-intercept. So I have enough to write the equation for my line. And I can use slope-intercept form. Y equals mx plus b. So y equals, my slope is -3/2. So it's -3/2 x. My slope, my y-intercept is 7. So -3/2 x plus 7. There's the equation for this line right here. Okay, let's find the slope and the y-intercept for line 2. Well, the y-intercept is at this point right here. So that's my b. B is 1. Now let's find the slope. So I like my point at 1. Another point that would be a good one is this point. So let's see. I have to go down 3 and right 2 to get to that point. What if I need to get to another point? I would go up 3, 1, 2, 3, and over 2. So up 3 over 2. So for line 2, since my line is falling, my slope, which is rise over run, will ultimately end up being -3 over 2. And my y-intercept, we said, is 1. So I have the y-intercept, I have the slope, so I have enough to write the equation for this line in y equals mx plus b form. And that would be y equals -3/2 x plus 1. Now, graphically, let me go through and look at these, pull this down. Graphically, when we look at the graph of these lines, we can see pretty much that these lines are parallel. Parallel lines never intersect. So this pair of lines are parallel, and this pair of lines are parallel. The distance here between the points is the same, same here. Let's look at their equations. So what do you notice about their equations? What do these have in common? The slope on this graph is -3/2, and the slope of line 1 is also 3/2. So what can we say about parallel lines? Well, parallel lines always have the same slope. So what makes lines parallel? The only way two lines or two or more lines are parallel is if they have the same slope. So finding the slope of a line is going to help determine information about parallel lines. All right, so let's look at the next little deal. Okay, so when we look at this example E and F, we'll notice that each pair of lines, they are definitely not parallel because they are intersecting. They do intersect. So there's also something special about the way they intersect. Each of these intersections, there is a symbol right here that is important information that tells us some information about these lines and how they intersect. these two lines are intersecting to form right angles. In fact, all four angles of the intersection will be right angles. So these are all intersecting to create four right angles. So right angles here as well. So now I want us to talk about each pair. So with parallel lines typically are going, well, not typically, but they always go in the same direction. Notice that these pairs of lines are not going in the same direction. We've got this line that's going kind of vertical up and down, and we have this line that's kind of going side to side or left to right. So these two lines definitely intersect, and I want us to write the equation for each of these lines. So let's let the blue line be line 1, and we will let the red line be line number 2. So what do we need to write the equation for, and I'm going to make this a little smaller. So what do we need to write the equation for a line? We need two things. We need the slope, and we need the y-intercept, or simply a point. So let's take a look at line number, well, let's go ahead and we'll just do this in order. Let's look at line number 1. So let's determine the slope of line number 1 first. Ooh, we're going to have to find some good points here. So this point right here is a good point. Where is another point that intersects the X and Y grid at the nice pair of crosshairs? It looks like right here. So my slope will be up 1, 2, 3, 4, 5. So I have risen, so rise over run. I go up 5, and then all I have to do to get to this point is go over 1. So 5 over 1, the slope is 5. Okay, it's a pretty steep line, so it makes sense that the slope is a nice integer. So now let's see what other information we can come up with. With line 1, this point is a good point. This is the y-intercept, which is great. So if my y-intercept is -5, then I can write the equation for this line in y equals mx plus b form. Easy enough. So what is my slope? My slope was 5. Multiply that by the x, and my b value is -5. Okay, so this is the equation for the line 1 in this example. Now let's focus on line 2. Now, okay, so let's find the slope of line 2. Ooh, goodness. So I'm going to take this point right here, and I'm going to figure out what my rise and run is until I get over here to this point. So I have to go down 1, so that'll be a -1, and then I have to go to the right 1, 2, 3, 4, 5. So my rise over run, let's see, my rise is -1 because I went from here down, and my run is, what did I say that was? 1, 2, 3, 4, 5. So my slope for this line is -1/5. All right, now let's talk about, all right, so this particular line, it is way too difficult for us to determine the y-intercept. So I'm going to have to use a different point. Now what I would suggest us use is either use this point, which has an ordered pair of -4, 1, or use this point, which has an ordered pair of 1, 0. Now I'm not going to lie, I like this point I like this point because it has a 0 for one of its values. So my point that I'm going to use is 1, 0. So now I'm going to use, because I have a point and the slope, I'm going to use point slope form. So I have y minus y1 equals m times x minus x1. So what is the y value of the point? And that would be 0, equals the slope is negative 1/5 times x minus the x value of the point is 1. So the equation here, if I clean this up a little bit just by dropping off that 0, is negative y equals negative 1/5. I'm going to go ahead and distribute negative 1/5 x, and negative 1/5 times negative 1 is positive 1/5. So here's the equation for line number 2. So here we had two lines that intersected to form 4 right angles. What you may have already determined, or actually no, we've talked about this a little bit before, but because these two lines intersect to form right angles, what we say is that these are perpendicular lines. Perpendicular lines will intersect to form 4 right angles. Always. That is the relationship graphically. This is the relationship graphically between perpendicular lines. They will intersect to form 4 right angles. Okay, so let's go ahead and do this example, and then we'll conclude this lesson, or this video for this lesson. So once again, let's label some of our lines. Let's let the blue line be line 1, and we'll let the red line be line number 2. So let's see what we can determine from this line. I'm going to have to make this just a little bit bigger, so I hope it doesn't mess anything up. Okay, so for the line 1, my point, the y-intercept of this point is at 2. So that's good. I know that the y-intercept is at 2. And, ooh, this graph is kind of tiny. So let's see what the slope is going to be. So I'm going to find, I think, this point and this point. So I have to go up 1, 2, up 2, and over 3, up 2, over 3. So my slope is 2 over 3. So my slope is rise 2, run 3. My equation, y equals the slope, 2/3 x, plus 2. All right, so now let's determine the same information, if possible, for line number 2. So line number 2, they intersect here at 2, so that's good. The y-intercept for line 2 is also, is 2. So now let's determine the slope. Okay, so I think this is a good point. And this is a good point. So let's see what happens. 1, 2, 3. I go down 3, right 2, down 1, 2, 3, right 2. So my slope for this line is down 3, right 2. So my slope is negative 3/2. So let's look at the equations. So we'll look at the equations and, or write the equations. So this will be y equals negative 3/2 x plus 2. Okay, so here's our equation for line 2. Here's our equation for line 1. And I want us to see what the relationship is between perpendicular lines and their slopes. When you have lines that intersect at 4 right angles, that means that those lines are perpendicular, and there is something specific and special about the slopes of the lines. So, what do we notice about the slope of, what do we notice about the slope of the perpendicular lines for this example and the slope of the perpendicular lines for this example? If you notice that wait a minute, something's not right. I don't know why. Hang on a minute. Something's not right. Yeah. I'm sorry. I highlighted the wrong thing. Ignore this. I need to ignore that. I highlighted the wrong thing. Now, let's compare these two. Notice that 1 and 1/5 are reciprocals. Notice that they have opposite signs. Notice that the slope of this line is 2/3. The slope of this line is 3/2. They are reciprocals and they have opposite signs. So the relationship between what makes lines perpendicular is that perpendicular lines have opposite reciprocal slopes. One slope has to be positive, one slope has to be negative, and then their slopes have to be reciprocals. And so that's the relationship between parallel and perpendicular lines. So I'm going to conclude this video so that you can kind of digest that a little bit, and then we'll pick up with the next video for part 2 of this lesson.